What's going on, everyone? Today's objective, I can describe a proportional relationship using an equation. So the two important parts of our equation, there are three parts, but two important parts are going to be what we call our dependent variable and our independent variables. Dependent variables usually denoted with the letter y. Dependent variables depend on our independent variables. Okay, that means that the dependent variable will change based on the value of the independent variables. And the independent variables, usually denoted with the letter x, do not depend on anything, meaning that we are the ones who control what happens with our inputs, the x values, in order to change the y values. All right? And this is the equation of proportional relationships. So they fit this equation, y equals mx. We're also, I don't like to talk about, but we also are going to see it represented like this: y is equal to k times x. K stands for our constant of proportionality. I want to use M because M is what we're going to use in the future. M represents our constant of proportionality. It could represent a slope, a rate of change, a unit rate, all those different values. But either way, just knowing K and M could be used interchangeably. So let's actually go right to an example. So here's what the problem says. The cost for 2.5 pounds of meat is $7.20. Find the constant of proportionality. Then write an equation relating cost to pounds, and then it asks how much will 4 pounds cost. So there's three different things they want us to do here. I'm going to split them up into A, B, and C. All right, so let's go with what the first thing says. So the cost for 2.5 pounds of meat is $7.20. Find the constant of proportionality. Okay, so let's do that first. Cost for 2.5 pounds of meat is $7.20. So my ratio in words is going to be the price, or the amount of money, per pound. All right. Well, we know that that's going to be $7.20 per 2.5. 2.5, I know I could represent as 2.5. But we know how to convert improper fractions, mixed numbers to improper fractions, and it can be worked with like that. All right. So now we have $7.20. $7.20 divided by 2.5 pounds of meat. And my constant of proportionality is going to be $2.88. All right, that's equal to my constant of proportionality. Or I'll even say it's equal to my M value for now, which we are calling the constant of proportionality. All right, so there we go. We found our constant of proportionality. Now let's write an equation relating cost to pounds. Okay, so B, we want to write our equation. Remember, the equation of a proportional relationship is y is equal to m times x. In this case, we could just specify what everything is. So our dependent variable, so our y value, is going to represent the cost, because the cost depends on the pounds of meat, so pounds. All right, so our dependent variable is cost, our independent variable is pounds. So if I'm to rewrite my equation, here's what it would look like. Y is equal to, what is my constant of proportionality? Well, it's 2.88 times x. And what this says is that if I multiply $2.88 by a certain number of pounds, I will have the cost. Last part. How much will 4 pounds cost? Okay, well, let's substitute. So we're going to take that equation, y is equal to 2.88x, 2.88x, but instead we're going to substitute in 4 pounds. So where would the pounds go? Well, pounds we identified up here was our independent variable. So that means I'm going to rewrite y is equal to 2.88 times 4. And when I multiply those values, I will get I'll put a little arrow, that y is equal to, I just had it up before, $11.52. So how much will 4 pounds cost? I could write out 4 pounds will cost $11.52. And there it is, equations of proportional relationships and how to use them.